Imagine a visitor from the stars, hurtling through the vast emptiness of space, not toward our blue marble Earth, but straight toward the rusty red world of Mars. What if this cosmic traveler, an interstellar comet named 3I/ATLAS, isn't just passing by harmlessly? What if its path is veering dangerously close, perhaps even on a collision course? As of September 2025, astronomers at Harvard University and NASA's experts are on high alert, scrutinizing every data point with intense focus. This isn't science fiction. It's unfolding in real time, a story that blends cutting-edge astronomy, planetary defense, and the thrill of discovery. Welcome to this in-depth exploration of one of the most intriguing cosmic events of our era. I'm your host, and today we're diving deep into the saga of 3I/ATLAS, its potential brush with Mars, and what it means for our understanding of the universe. Stick around, because by the end, you'll see why this matters to every one of us on Earth. And if you're excited about space science, hit that like button now and subscribe for more updates. Who knows what we'll uncover next? Let's start at the beginning, because every great story has origins that captivate the imagination. On July 1st, 2025, under the clear Chilean skies, the NASA-funded Atlas telescope in Rio Hurtado captured something extraordinary. Amid the routine scan for near-Earth objects, a faint dot appeared, moving against the backdrop of stars in a way that defied expectations. This wasn't just any asteroid or comet. Its trajectory screamed interstellar. Name 3I/ATLAS. The 3I denoting the third confirmed interstellar object after Oumuamua in 2017 and Borisov in 2019. It was hurtling into our solar system from the direction of Sagittarius at an astonishing speed. Picture this: while typical solar system comets meander at speeds influenced by the sun's gravity, 3I/ATLAS boasts a hyperbolic excess velocity of about 58 kilometers per second, fast enough to escape any star's pull and wander the galaxy for billions of years. Discovered by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a network designed to spot potential threats to Earth. This comet's arrival was serendipitous, but as data poured in from telescopes worldwide, including Hubble and the James Webb Space Telescope, excitement turned to urgency. Why? Because its path wasn't a safe flyby. It was slicing perilously close to Mars, prompting warnings from Harvard's astrophysicists and putting NASA's planetary defense teams into overdrive. This discovery isn't just about spotting a comet. It's a window into the cosmos beyond our home, reminding us that the universe is full of surprises that can rewrite our textbooks overnight. To truly appreciate the drama, we need to rewind a bit and understand what makes interstellar objects like 3I/ATLAS so special. Our solar system formed about 4.6 billion years ago from a swirling cloud of gas and dust, birthing planets, moons, and a vast population of comets and asteroids. But out there, in the interstellar medium, the space between stars, similar processes occur around other stars, ejecting icy bodies into the void. These wanderers, rogue comets and asteroids, drift aimlessly until gravity from a passing star like our sun snags them. Oumuamua, the first, was cigar-shaped and tumbling, sparking debates about its nature. Borisov was more comet-like, with a visible tail. Now, 3I/ATLAS enters the stage as the third, but it's already proving to be the most enigmatic. estimated to be up to 5.6 kilometers across, larger than the previous two. Its nucleus is a frozen relic, possibly billions of years old, predating our own solar system. According to models from astronomers like those at the University of Oxford and Otautahi, it could be nearly 7 billion years old, making it the oldest comet we've ever observed. That's like holding a piece of the early universe in our observational grasp. As it approaches the sun, solar heat vaporizes its ices, creating a coma, a glowing atmosphere of gas and dust, and potentially a tail. But 3I/ATLAS is showing quirks, a high carbon dioxide to water ratio of 8:1, far richer in CO2 than typical comets, suggesting it formed near the CO2 ice line in its parent star system or endured intense radiation during its long journey. Observations from JWST on August 6, 2025, revealed water ice, carbon monoxide, and even carbonyl sulfide, painting a picture of an object that's both familiar and alien. This isn't just a rock from space. It's a time capsule carrying chemical signatures from a distant stellar nursery, offering clues about how planets form elsewhere in the galaxy. Now, let's zoom in on the heart of the alert. 3I/ATLAS's trajectory and its unnervingly close shave with Mars. As of mid-September 2025, the comet is barreling toward the inner solar system, set to reach perihelion, its closest point to the Sun, on October 29th at just 1.36 astronomical units, or about 203 million kilometers, slipping inside Mars' orbit. But before that, on October 3rd, it will make its closest approach to the red planet, passing within approximately 30 million kilometers, about 18 million miles, or 0.2 astronomical units. That's closer than its 1.8 astronomical unit passed to Earth in December, making Mars the star of this cosmic show. NASA's Jet Propulsion Laboratory has been running orbital simulations, refining the path with data from Hubble, which imaged the comet on July 21st, showing a teardrop-shaped dust cocoon, and JWST, which probed its composition, the uncertainty ellipse. The range of possible paths, due to measurement errors, has narrowed dramatically, but not without raising eyebrows. Harvard astronomers, particularly from the Center for Astrophysics, have been vocal. Professor Avi Loeb, known for his bold hypotheses on extraterrestrial tech, led a team that analyzed the data, warning in a preprint paper that the comet's trajectory could intersect Mars if influenced by outgassing or other forces. While NASA emphasizes no collision is imminent, the probability, though low, less than 1%, is enough to trigger protocols. Think of it like a game of cosmic billiards. At 58 kilometers per second excess speed, ramping up to over 60 kilometers per second near Mars, even a slight nudge from gas jets could alter the course by thousands of kilometers. Internal models at JPL show the closest approach at 1.95 million kilometers in some simulations, well within Phobos's orbit, prompting the Planetary Defense Coordination Office to elevate monitoring. This isn't panic, it's preparedness, a testament to how far we've come in tracking potential threats, not just to Earth, but to our solar neighborhood. Delving deeper into the science, the warnings from Harvard stem from meticulous computational work that's as thrilling as any detective story. At Harvard's Center for Astrophysics, Harvard and Smithsonian Teams use high-performance clusters to run Monte Carlo simulations, thousands of orbital predictions factoring in every variable, from gravitational perturbations to cometary activity. On September 14, 2025, a routine fit revealed the uncertainty shrinking faster than anticipated, cutting the Mars approach distance by hundreds of thousands of kilometers in a week. Graduate students, fueled by late-night coffee, cross-referenced data from the Very Large Telescope in Chile and Gemini South, noting the comet's 17-minute periodic pulses of gas, cyanogen and CO, creating a sawtooth brightness pattern. These aren't random. They're rhythmic, like a heartbeat, potentially acting as natural thrusters that could steer the path unpredictably. Professor Loeb's team, in collaboration with dynamicists from the Black Hole Initiative, flagged this in encrypted communications. This isn't a drill. The covariance matrix, the statistical measure of error, collapsed to less than the Earth-Moon distance, triggering a draft alert. NASA's response was swift. JPL requested Harvard solutions, integrating them with Hubble's astrometry. As of September 16th, the best fit trajectory places 3-A TLAAS at 1.95 million kilometers from Mars, but outlier simulations, those 3 sigma tails, skirt as close as 50,000 kilometers, closer than Deimos. This razor-thin margin, combined with the comet's retrograde, high-inclination approach at 87 kilometers per second relative to Mars, has planetary defense analysts on edge. It's not about doomsday. It's about the unknown. If a pulse tips it just right, the impact energy could rival millions of megatons, reshaping Mars' surface and endangering our missions there. Harvard's measured public statement belies the tension. Every time-stamped data point is triple-checked, hourly models run, underscoring the human element, the passion of scientists racing against cosmic time. Shifting to NASA's side, the alert has mobilized the agency's vast resources in a display of coordinated brilliance. At the Jet Propulsion Laboratory in Pasadena, trajectory analysts, seasoned from tracking near-Earth asteroids, pivoted to this interstellar wildcard. Data from Hubble and ground arrays revised the close approach yet again, shrinking the safety margin to lunar mission scales. Dr. Lindley Johnson, head of the Planetary Defense Coordination Office, raised the internal flag when models showed a non-zero risk tail. This triggered cross-checks. The Mars Reconnaissance Orbiter, MRO, tasked with high-cadence imaging, Deep Space Network radars at Goldstone aiming to resolve the nucleus. Liaisons from PDCO joined briefings, a reminder this transcends academia. NASA's statement remains calm, no threat to Earth, closest at 1.8 astronomical units. But internally, consensus is clear. The risk, remote as it is, demands action. Assets like MRO's high-rise camera, with its 0.3-meter resolution, will peer at 3I/ATLAS during the October 3 flyby, potentially capturing details of its 440-meter to 5.6-kilometer nucleus. ESA's Mars Express and Trace Gas Orbiter are coordinating, planning spectral observations with instruments like NOMAD and ACS to analyze the coma. Even private players like SpaceX are assessing impacts on future Mars plans. This escalation, adapted from the Torino scale, recognizes consequences. Mars hosts billions in international hardware. Perseverance, Curiosity, Zhurong, a collision, improbable but possible, could vaporize rovers, shred orbiters with debris. NASA's doctrine of measured response ensures we're ready, turning potential peril into scientific gold. If you're fascinated by how agencies collaborate on cosmic challenges, share your thoughts in the comments below. What would you do if you were in mission control? At the core of 3I/ATLAS's intrigue lies its bizarre behavior, a puzzle that's kept observatories buzzing from Cambridge to Mauna Kea. Unlike standard comets, which vent chaotically as sunlight hits uneven ices, this one pulses every 17 minutes with metronomic precision. Time series data from Gemini South, validated by Hawaii's arrays and space platforms, show a surge in cyanogen and carbon monoxide, creating a visible sawtooth in brightness. Spectrographs confirm the plume aligns with velocity shifts, each burst nudging the path measurably. Harvard's photometry logs microaccelerations syncing with these events, feeding trajectory models. It's as if the comet has an internal clock, defying gravity-only predictions. No known solar system comet pulses this way. Ordinary outgassing is messy, tied to spin or cracks. Here, the regularity suggests resonance, perhaps a binary structure or harmonic oscillation in its nucleus. Implications are profound. These thrusters introduce variability, where each pulse could widen or narrow the Mars margin. Global networks plot the next eruptions, debating if it's natural or hints at something stranger. JWST's August observations revealed a reddish coma from dust, with atomic nickel vapor but low iron, unusual markers. The green glow captured during September's lunar eclipse, possibly from unfamiliar molecules mimicking dicarbon, adds to the enigma. Is this periodicity a relic of its formation, or evidence of exotic chemistry from intense interstellar radiation? As the countdown ticks, late-night observatory debates intensify. 3I/ATLAS isn't just moving, it's dancing to its own cosmic rhythm, challenging our models and igniting curiosity about the universe's hidden mechanics. Public reaction to this interstellar drama has been electric, blending awe, speculation, and a touch of cosmic anxiety. Social media exploded after Harvard's alert, with hashtag 3IATLAS trending worldwide. Podcasts dissect the Mars shield theory. Could the red planet absorb a hit meant for Earth? A pop sky poll showed 60% viewing Mars as a bodyguard, its position fortuitously in the line of fire. But experts like Dr. Neutron caution, at 10 billion tons, an impact unleashes 2 million megatons of TNT, enough to crater 60 kilometers wide, vaporize ice, and hurl debris interplanetarily. While Mars' mass stabilizes its orbit, fragments could drift toward Earth, though risks remain remote. Forums abuzz with what-ifs. Chain reactions destabilizing the inner system. Dynamicists unanimously say no. The energy's immense, but planetary scales dwarf it. Yet, the psychological ripple is real. This is humanity's first real-time planetary defense for another world. Avi Loeb's paper suggesting artificial origins, citing the trajectory's convenience touring planets, fueled alien tech debates, though NASA debunks it as natural. Misconceptions abound. Some fear Earth impact, but at 1.8 astronomical units minimum, it's safe. Others mythologize the pulses as signals. They're likely natural. This event humanizes science. Enthusiasts share eclipse photos of its green glow. Students model orbits in classrooms. It's a teachable moment, fostering wonder. What do you think? Natural wanderer or something more? Comment below, like if this sparks your interest, and subscribe to stay updated as October approaches. Your engagement helps spread this knowledge. Visualizing the risk brings the abstract to life, much like a detective piecing together clues from a crime scene. In NASA's control rooms, Monte Carlo outputs paint fan-shaped diagrams, sprays of possible futures for 3I/ATLAS. The core, the best fit path, threads 1.95 million kilometers from Mars, safe passage. But the wings, lighter shades of uncertainty, hold the tension, outliers skimming 50,000 kilometers, grazing Deimos. Each line stems from relentless computation. Hubble's decimals, JWST's images tighten the curve. The 1 sigma zone is secure, but 3 sigma tails whisper warnings. To the layperson, 1.95 million versus 50,000 kilometers seems trivial, but in orbital mechanics, it's a chasm. Probability density speaks volumes. Even 1 in 10 million odds, multiplied by stakes, demand vigilance. Colored bands, deep blue certainty, pale yellow extremes, evolved by September 16th. Edges contracting, yet tails lingering. Hourly, astrometry carves away danger. But caution prevails until outliers vanish. For planners, the sliver drives contingencies. The fan is a living risk map, shrinking from solar system width to a pixel. That pixel, it's why the world watches this icy wanderer. As data logs fill, the diagram's shape, its narrowing, will decide near miss or bullseye. Until the final point, the fan stays open, a silent cosmic timer. Behind the scenes, NASA's Planetary Defense Coordination Office embodies vigilance, escalating alerts with precision, typically Earth-focused. 3I/ATLAS, forced adaptation, shrinking ellipse, risk tails in Mars gravity, simulation impacts, triggered scrutiny, PDCO protocols, echoing Torino, hit thresholds when outliers brushed 50,000 kilometers. Hours after JPL's September 16th ensemble, briefings convened ESA, Roscosmos, CNSA, ESRO via secure links. Agenda, trajectories, mission risks, contingencies, classified bulletins urge telemetry boosts, asset repositions, MRO imaged inbound paths, DSN radars refined vectors, ESA's Darmstadt reviewed trace gas protocols, SpaceX Lockheed-eyed launches, thresholds weigh consequences, Mars fleet, billions invested, demands response. No public alarm, but subtext clear. Prepare. This machinery, now Mars Ward, highlights defense's evolution, from theory to action. Every step, from data exchange to radar locks, underscores readiness. The next pulse. It could seal near miss or event. In this ballet of agencies, humanity safeguards its outposts, turning alert to opportunity. Should 3I/ATLAS collide, improbable but modeled, the consequences for Mars would be cataclysmic, a stark reminder of cosmic fragility. At 10 billion tons, with a possible 400-meter metallic core, impact energy hits 2 million megatons, thousands times humanity's largest nukes. A 60-kilometer wide, 5-kilometer deep crater dwarfs Arizona's Barringer, excavating rock, vaporizing ice. Shock waves race through thin air at supersonic speeds, barraging spacecraft. MRO, trace gas, Tianwen-1, Perseverance faced debris, hail, comms sever, data lost, climate records, imaging, life hunts erased. Simulations show nothing survives blast zones. Perseverance, 3,000 kilometers away, might endure, but orbiters risk ejector. Far-side assets face quakes destabilizing landers. Debris clouds threaten satellites years long, crippling monitoring, mapping, relays. Billions in hardware, generations legacy, gone in an instant. Engineers, decades deep in design, face devastation. Stark numbers, 2 million megatons, 60-kilometer scar, global fallout. Defense now Mars inclusive, eyes on updates, one pulse deciding preservation or loss. Beyond immediate blasts, long-term effects reshape Mars' narrative. Sobering climate models projecting aftermath. Vaporized millions of tons form mushroom clouds, ejecting into orbit. A dense ring shadowing surfaces, endangering craft. Thin atmosphere yields little drag. Dust storms whip planet-wide, months long. Plunging temps dozens of degrees. Global winter halting missions, choking panels, obscuring views. Atmospheric escape accelerates, stripping gas, thinning air, dimming habitability hopes. Exposed ice sublimates briefly, adding vapor lost to space. Fragments at escape velocity drift interplanetarily. Meteoroids crossing Earth, remote but tracked. Recovery, Mars scars, ancient basins, attest resilience. But this modern wound rewrites climate, processes, life search models. Ripples echo Mars as home debates. A single hit alters trajectories for colonization. For scientists, it's dual, loss and gain. New data on impacts, but at what cost? History offers lessons, none more vivid than Shoemaker-Levy-9's 1994 Jupiter plunge. Fragments scarring Earth-sized. Hubble captured, birthing defense imperatives. Tools born then, surveys, models, protocols, Earth-centric. 3I/ATLAS exposes gaps. No Mars network, no treaties for other worlds. If Earthbound, evacuation only. For Mars, no fallback. Policy shifts. NASA ESA CNSA drafts for data sharing. Voluntary. Private sector joins, pushing standards for infrastructure, humans. But tech lags. No deflection for 10 billion-ton hyperbolics at 90 kilometers per second. Shoemaker showed hits. 3I/ATLAS limits. Next may target colonies. Drive for defense, survival, multi-world. If inspired, subscribe for responses to challenges. Building safer stars. In wrapping this epic, recall 3I/ATLAS. July discovered interstellar comet. Hurdles to Mars, October 3rd. 30 million kilometers close. Harvard NASA alerted by shrinking uncertainties, pulses. No Earth threat, but defense test. Bizarre, CO2 rich, ancient, rhythmic, universe clues. Simulations fan risks. Agencies mobilize. History warns. Educational engaging. Curiosity sparked. Like, subscribe, comment thoughts. Engage. Thanks watching. More soon.